All right, welcome, ladies and gentlemen. I am back to finish off my live stream that I started earlier. So for that first portion, basically what I did is I went through the exam solutions 1 through 26 for my pre-calculus class. Now, we only really got to in the middle of rational expressions. So we covered, in this case, functions, we covered polynomials, and then we covered rational expressions. So I went through 25 questions. You can see I'm showing my work, showing the answer. I did forget my answer choices, so hopefully I remember the answers that I kind of went through, especially as I work through them. So. But that's what we covered in the first live stream, and then I had to go and get my kids. So I was like, crap, I'll go ahead and finish this. And that's exactly what I want to do. I just want to show you guys, some of these as we did. We did some functions, piecewise functions, inverses of functions, transformations of functions, domain and range, and all that kind of stuff. So if any of these questions are of interest to you and you want to go and check part 1 because you weren't able to catch the live stream, then please go ahead and check part 1. I don't have a card or a screen set up now, but I'll work on that after this live stream is over, so therefore you guys have an easy way to catch this. I'm also going to put up a link to a free download and for you on this study guide. So therefore, if you want to use this to study for, algebra 2, trigonometry, pre-calculus, calculus, you just want to see my answers, I'll have that all available to you after I am done with this live stream. So I got all the way up to 27. I have a total of 45 questions left, so we still have some problems to do in rational functions, and then we're going to get into trigonometry. So hopefully any of you guys that are interested in the trigonometric portion of our review, then we will get started with that. So let's go ahead and get started on this 27. Just want to make sure that I have this real quick. Let me look at my... Okay, perfect. Ghost asks, not to be erratic or anything, but are you going to go over cosine, tangent, and arctangent stuff? Yes, I am. And unfortunately, though, I'm going to go in order. But so if you don't really care about the rest of this stuff, you can maybe wait like 20 minutes, 30 minutes, and I'll get to it. But you can see here for like 39, 40, we're going to talk about evaluating. We're going to talk about the graphs as far as like sine and cosine, or I'm sorry, is like the range and domain, and then we're going to talk about the inverses here as well. So when I go through each of these questions, I'm not going to get in detail explaining them because this is a review, but I do spend a little bit of time. That's why it took me like an hour just to do 25 questions, because I do explain the problem. I do explain or at least the purpose is I want to explain the approach and what I'm thinking when I'm going through these problems, because obviously, on your exam, you're not going to have these exact same questions, or at least, possibly, more than likely or not, you're going to have the exact same question, but you're probably going to have something similar. So understanding the approach and what you're thinking is going to be more important than just say, oh, here's the shortcut, how to get this answer. So I will be coming to those, but it's just not going to be very shortly. I'm going to spend about, probably 20, 30 minutes will probably take me to get through these. So, and then obviously the replay will be available for you. Or you can just come on and hang out. Say, hey, Justin, how are you? To be random, your videos have definitely helped you out. That's all right, Justin. I haven't started yet. What I did do in my first live stream, though, is I kind of worked through each page. At the end of each page, I just kind of took a break and kind of said hi to you guys joining in on the chat. So I do appreciate you reaching out and letting me know that the videos have helped. And, I look forward to just kind of bringing in more content. And that's one of the things I like about the live stream is, it's a little bit different than the videos that I make in my class. Obviously, it's a different element. I can make videos now at home, do my live streams. I do the live streams after school. So it just kind of brings a different little dynamic to my channel. And then, obviously, if I have some time at the end of this live stream, I will answer some questions that if any of you guys have going on, either on what I'm covering or what I'm going to be, or what you have in your own classes. And then I'll also look into maybe doing a stream, maybe tomorrow, maybe Wednesday, of just answering some questions, having not agenda on my end as far as a schedule or anything, but just here to answer any questions, see if I can help. So, all right, let's go ahead and get back onto the math train and work on tackling vertical asymptotes of a rational function. Remember, our vertical asymptotes are discontinuities. They're values that make the denominator equal to 0, but they're also values that make the denominator 0 that are not divided out, because remember, when terms get divided out, those are wholes, not vertical asymptotes. So the first thing we're going to do, though, is you always want to simplify the numerator and the denominator. And this numerator, I can't really do anything with at this point, but if I factor out a negative, then I can rewrite this as x squared minus 16. Now it's in the form of difference of two squares. You could do it this way, but then still would have to multiply out a negative. So if you factor out the negative beginning, you can see we have a difference of two squares, which is easy to factor out. Over here, I'm looking for what two numbers multiply to give me 4, add to give me 5. That's going to be x plus 4, x plus 1. And so now I can see that, oh yeah, I can go ahead and factor this to x minus 4 times x plus 4, difference of two squares. And this is going to be x plus 4 times x plus 1. And again, the important thing is now by doing it this way, what I have done is I have rewritten this problem as a product of our factors. Now I can apply the division property. Now again, the x plus 4 is still a discontinuity, right? It's not a part of the domain, which we covered at the beginning in part 1, but it's not an asymptote. Vertical asymptote are what we call non-removable discontinuity. So the only value that's going to make the denominator 0 that is non-removable is going to be -1, because now you can just set x plus 1 equal to 0, and you get x is equal to -1. So C is going to be our only answer in this case that's going to make it, because x plus 4 is still a discontinuity, but it is a whole. All right, let f of x equal some crazy rational function. Find any horizontal asymptotes of the graph. So remember, when we're looking for horizontal, we're looking for the horizontal asymptote test. Rather than writing it down, I'm just going to verbally say it. When the degree in the numerator is larger than the degree in the denominator, like we have here, there's no horizontal asymptote. Done. If they were the same, let's just kind of play around with this. Let's just say it was 3x cubed over 5x to the 4th, then the horizontal asymptote would be y equals 0. And let's say they were the same. For instance, like 3x cubed over 5x cubed. Then the horizontal asymptote, now again, these are polynomials, not like expressions. Right? I don't want you to be like, oh, you could just divide those. Now, these are polynomial expressions. But now, if the degrees are the same, then you just take the leading coefficient over leading coefficient. So that would be y equals 3/5. Okay? But in this case, my power in my numerator is larger than the power in the denominator, so there's no horizontal asymptote. Find the x and the y intercepts. Now, this is one that I think comes up a lot with the students as far as on functions, and it seems like I'm not really sure why a lot of students kind of like forget this concept, because it's something very basic from when we learned how to graph lines. When you have a line here, you have an x and a y intercept, and there's something very, very important about these x and y intercepts. When you're looking at the x-intercept, the one thing you know is y is equal to 0. When you're looking at the y-intercept, the one thing you know is x is equal to 0. So we can replace this r of x notation with y representing the output variable. And the main important thing, guys, is when you want to find the x-intercept, y is equal to 0. When you want to find the y-intercept, x is equal to 0. So if I want to find the y-intercept here, I'm just going to replace 0 for x. So when I do that, I end up getting -18 over 6, which gives me -3. And what do you know? There's only one answer where the y-intercept is going to equal to -3, which is my answer C. Now let's just double check to make sure that the x-intercept is 18. So if I was going to check the x-intercept, I would replace y with 0, and I'd have 0 equals x minus 18 over x plus 6. Well, what you notice whenever you have a rational function equal to 0, whenever you multiply that denominator on both sides, you're just going to have 0, the numerator, equal to 0. And of course, we can see that x is equal to 18 is the x-intercept. So therefore, we can confirm our answer C. Number 30 says list the x-intercepts and type of symmetry. So again, kind of going through the same rules here. Let's go ahead and find the x-intercept. So the x-intercept, I'm going to put y equals 0. But again, like I'm going to multiply the denominator on both sides. So I'm going to start using a shortcut here of just setting the numerator equal to 0. And again, this only works here for a rational function like this. But therefore, we get x equal to 0. And then when I want to find the y-intercept, I put x equal to 0. But notice when you have 0, 0, minus 6, you're going to get y is equal to 0. So my x and y intercept are both occur at the origin, which is 0, 0. So that is not its answer. Now I got to go ahead and test the symmetry. And this is not in function notation, so I'm going to write it in function notation. F of negative x is how we test our symmetry for at least the x and the y axis. I'm sorry, for the y-axis and the origin, as far as even and odd. That's at least what we discussed. We didn't really discuss the reflection about the x-axis as origin. That'd just be something different. That would just be negating the y and kind of seeing if that gives you the same value. So anyways, when I go ahead and plug in f of negative x, I get a negative x to the, negative x to the negative x to the fifth all over x squared minus 6, that's a negative x squared. And when I plug that in, that gives me, that's still a negative, so now that turns into a positive, x to the fifth over x squared minus 6. Now, it might not look like, well, it's not the same, exactly the same as this, so it's not going to be, it's not even, it's not symmetrical about the y-axis. And then you might say, well, is this the opposite of f of x? And remember, if you have f of negative x is equal to opposite of f of x, then it's symmetrical about the origin, or it's odd. And if we look at this, if we were to take the opposite of f of negative x and we just applied that negative to the numerator, you can see that this can be rewritten as that. So it is symmetrical about the origin. Because again, I could just distribute that negative into there, and again, you get the same. So when you add f of negative x is equal to opposite of f of x, then that's going to be symmetrical about the origin. So the answer is going to be D. Next one, given the domain and range for the rational function, use interval notation. All right, now this one's kind of interesting because immediately, like when I first looked at that problem, I'm like, oh, reciprocal function, like vertical asymptote at 3, horizontal asymptote at 5. And then I'm like, well, the range isn't correct then. So, and then I took a closer look at it. I'm like, oh, I'm moving too fast, right? Notice this 2 here. That changes everything. I don't know what this graph looks like, right? I mean, it's not hard. I could plug it into a calculator, but off the top of my head, I don't have a good picture of what this graph looks like. So what I can do is, if I remember, I can find the domain. That's easy. That's the values that are going to make the denominator equal to 0, where it's going to be all real numbers except for 3. So I know that basically those 2 answers don't work, right? Because you basically for the domain, set the denominator equal to 0 and solve x is equal to 3. So those are the values that make the denominator equal to 0. Now to find the range, what I'm going to use is I'm actually going to use inverse functions. I remember that the range of a function is the domain of its inverse. So I'm going to go ahead and figure out what the range is. So I'm going to replace this with y. And remember, we now just swap our x and our y variable. So in this case, I'm going to have x is equal to 1 over y minus 3 squared plus 5. And then to go ahead and solve for y, I'm going to subtract a 5. X minus 5 is equal to 1 over y minus 3 squared. I'm going to need to multiply that on both sides to get it off the denominator. This is actually a better question in the functions unit than the rational expressions, but it's a good one to review here. So those will divide out. And then to solve for y, I'm going to put the x minus 5 in parentheses. I'm going to need to divide by x minus 5. So now I have y minus 3 squared is equal to 1 over x minus 5. And now to get rid of the squaring, I need to go ahead and take the square root. So when I square root both sides, obviously I don't need to take this, like I can break up the square root in the numerator and denominator. So therefore, I'll just move this over here. I'm going to be left with y minus 3 is equal to 1 over the square root of x minus 5. Now, I'm just going to stop here. I'm not even going to go through the inverse because it's not asking me for the inverse, but I can see that this is going to be true for all values that are greater than 5, but not including 5. So obviously these are my only two answers, and then this is the only one that would make sense. So that's going to be answer C. All right, last one. We got two more in rational functions. Actually, I'm going to go and take a break here. I think I got two more pages left. We're going to be working till 45. I can see DJ23, hello, I'm in 9th grade. Well, this is pre-calculus, and I have 10th graders, 11th graders, 12th graders. I don't think I have any 9th graders on the pre-calculus, but don't worry. A lot of this stuff, especially what I've covered up to this point, is some stuff that you would see in, Algebra 2, and possibly even into some, advanced algebra classes as far as a lot of the algebra and stuff like that. So it's nothing like out of your realm. Obviously, when we get into trigonometry, that's something that is, held until the end of Algebra 2 and the pre-calculus as well. I'm in 10th grade. I barely understand this. Well, not a problem, man. It's not anything. This is a review. I'm doing this review for my class. So I am instructing not from a let me teach you how to do this point of view, but basically let me remind you of stuff that we've already learned kind of point of view. So, a lot of the stuff I'm not doing a full explanation on. I am kind of moving through it on that. And the Kitty Gamer Minecraft, hola, we're back. Are you going to have this on Focus? Yes, I will. Well, not on Focus. This will be on my website for you guys for this. And then, hey, Miss McLogan, Ellie. Well, hey, Sam, how are you? Thank you. My exam's at 8 a.m. Well, awesome. I am going to continue doing this. I think I put my list. I think I put my end. I will stop the stream at 10:30, but I think I can get through 40. I think I can get through almost 10 more questions in an hour, so that'll be all right. But if you have any more questions, after I'm done with this, at least working through my review, then feel free to ask them. I'm happy just to kind of go over anything else from you guys. Sandra says, thank you for passing AP Calc. Well, congratulations, Sandra. That is awesome. Congrats to you. AP Calc is a lot of work. I know from helping, teaching AP Calc for the last 2 years, it's a lot of work on the teachers, and I know it's a lot of work on you guys. I mean, I gave my students a lot of work, to push that, exam. So congrats to you. That is definitely something you should be proud of. And Thomas, I'm sorry, man, your teacher cannot teach. It is, I think we've all been through the thing, and by no means, have I secured anything as far as like teaching or the way how to teach. But, I will say through the years, that's one thing that I've always just at least tried to improve. I'll get a lot of people that watch my videos from like 2010. And they're like, oh, you're a horrible teacher. You talk too fast, or like blah, 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 blah. And I'm like, yeah, it's like, I appreciate it, but, in the same respect, I have that video up there from 2010 just to help anybody out that's available. I would hope that my teaching, from 2010 is much worse than what I'm doing now. Like, I'm hoping what I'm doing now is much better than what I did in 2010. In the same respect, for next year, I'm hoping that I'm doing a much better job than what I'm doing this year. So, I think the role as a teacher is always to be improving, and I think if teachers, aren't improving, then yeah, that's an issue. And, but I think that the power of the technology that we can do nowadays, you guys don't need to feel constrained to, every teacher that you are assigned to, nowadays. We have the power of the internet where you guys can basically get an education online. And those are some of the things I'm looking into as well. Do I need to include the negative with the x minus 4 numerator? Well, I didn't simplify it, Mackenzie. And I'm sure which question you're talking about. Yeah, that negative does include. Oh, thank you. So that negative does stay. You're right. It just doesn't affect the asymptotes, though. So hopefully you're still on. But yeah, that negative would still be there. Forget about that. All right. You can make some advice. I'm a grad student. I'm taking up teaching at high school to help pay. I'm very worried about it. Hey, I found your videos online. I'm wondering if you could maybe give me some advice. Gray. Yes, Gray. I will give you some advice. hold on. For question 32, the answer is E. Well, I didn't get to 32 yet, did I? Yeah. Oh, Arson's getting right in front. All right. Well, let's go ahead and check. Let's see if he is correct. E, 32. Nice. All right. Well, let's go and see if it is E, which is a random question. Arson, thanks so much. All right. So now solving rational functions. I'll go ahead and take a break here. And after I'm done with this page, which I think is my second to last page. Yeah. Okay. Second to last page. So solving rational functions. This one gets a lot of student or rational equations. The main important thing again, guys, is we want to get rid of the fractions. So in this case, you can see I don't have same denominators. So what I'm going to do is I'm going to factor out a 2, and I get 2 times x minus 4. Now again, what I want to do is I want to eliminate the denominator. Like for instance, like if I have, I don't know, just put over here like x over 2 is equal to, 5 over 2. I don't need to like solve this. I don't need to do anything else. I know that just x is equal to 5 because you could multiply by 2 on both sides. You're going to get x equals 5. So our goal in this case is to basically identify our common denominator that we can go ahead and eliminate. So all I simply really need to do in this case is multiply here by x minus 4 times x minus 4. And then over here, I'll multiply by 2 over 2. So now all my denominators are the same. And basically, if I multiply everything by my LCD, so now basically what I did is I obtained the all common denominators. If I multiply everything times that LCD, all those denominators will be eliminated. Now, a lot of times you don't need to show this step. Once you kind of understand it, you can now just move to writing what is left over of the denominators. Okay? Because of what is left over of the numerators. And now I can just go ahead and solve equals 3x minus 4. That's wrong. What did I do? 3x minus 12, distributive property. Be very careful. All right, and so therefore, add 12, you get 15 equals 3x, divide by 3, x is equal to 5, which is answer D. All right, so number 33. Now, this one, it's not as obvious, what my common denominators are. So again, I'm going to do the same thing. I'm going to say, well, what can I can factor this, right? And we spent a lot of time in my class factoring and practicing factoring. And typically when you have a problem like this, usually when you have different denominators and then you have this expression here, you guys can see that it is going to be usually like the product or related to what your other denominators are. So now, to get them to all have the common denominator, oops, what am I doing? I'm like talking and going too fast. One of them has to be 3. So now I'll just multiply by y plus 4 times y plus 4. And then over here, I'll multiply by y plus 3 over y plus 3. Okay, and again, if you were to multiply everything times your LCD, I still like to be mathematically correct in showing that, even though I know some of you don't care to show that work, but that's mathematically what you're doing. And now we can just write our numerators. Now I'm going to move forward with my distributive property here. So now I get an equation that is y squared plus 3y plus 8y plus 28 is equal to 4y plus 16. So let's go ahead and combine like terms, and so therefore I have y squared plus 11y plus 28 equals 4y plus 16. Now if I subtract these on both sides, I have subtract a 4y on both sides and then subtract a 16 on both sides. I will now obtain y squared plus 7y plus 12 equals 0. And then now I'm just going to go ahead and factor this into x plus 4 times x plus 3 equals 0. So therefore my solutions are x equals -4 and x equals -3. But there is an issue, because remember, for our problems here is, now again, I kind of skipped over this step because obviously there was no answer for extraneous solution, so I knew whatever my answer was going to work. But in this case, you can see we have this no solution option. And basically no solution option comes from when you get your solution, that means it's a solution to like your simplified result, right? But it's actually not a solution to the original equation. And these are not solutions to the original equation because when I plug them into the equation, it makes the denominator 0. So these are actually what we call extraneous solutions. They're only solutions to our simplified result, not the original. So just remember, especially on a multiple choice, if you see that extraneous or no solutions, make sure you go back and check your answers. See, in this case, I'm like, I didn't really need to, because it's either I made a mistake and it's not 5, but I don't need to like check my answer, because if I made the denominator 0, I would need an option for it to be a no solution or extraneous. So, all right, guys, that is it for the rational sections part. Now we're going to get into the trig part. Now, in this equation, this was actually pulled from a previous chapter where we haven't talked about the identities yet. And we don't really need to use the identities for this one. We have theta as an acute angle, and sine of theta is given. And we just want to find, but we still want to find the cosine. So it just says find cosine of theta. Now, again, there's no restrictions or anything that's going on, so I can just go ahead and create a triangle. Just a nice little floating triangle, however I want to. So we'll put theta here in a box here. Sine, remember, is opposite over hypotenuse. If you're going to do Pythagorean theorem here, I'll have 4 squared equals 1 squared, and then let's just say plus a squared. And you guys can see, hopefully, by doing the Pythagorean theorem, this is going to be the square root of 15. It's not plus or minus. There's no direction that's going on here. So now if I'm going to do the cosine, remember cosine is adjacent over hypotenuse. Let's write these in there. Opposite over hypotenuse. So adjacent over hypotenuse is going to be square root of 15 over 4, which is d. Number 35 says find the measure of the two angles, one positive and one negative, that are coterminal with the given angle. So remember, coterminal angles are angles that have the same initial and terminal side. And the easiest way to find coterminal angles is either to add or subtract 2 pi or 360. Now, so the first thing usually what a lot of students will do is they'll add 2 pi, which in this case, in terms of my denominator, is going to be 6 pi over 3. So they'll add 6 pi over 3, and what you get is 14 pi over 3, which looks like that one shows. But I don't want to just select that answer because it says to find one positive as well as one negative. So if we notice, if we take 8 pi over 3 and we subtract 6 pi over 3, we also get another positive angle, 2 pi over 3. And we see that 2 pi over 3 works here as well. So we actually got 2 answers here. I'm not going to get 11 pi over 3, so those 2 are wrong. So now I got to figure out, well, which one then is going to give me the negative angle? So let's go ahead and subtract 6 pi over 3 again. So when I take, now I'm just going to go from 2 pi over 3. When I subtract 6 pi over 3, I end up getting negative 4 pi over 3. And I don't see that. However, if I take negative 4 pi over 3, that's a weird 3, and I subtract 6 pi over 3 again, then I get negative 10 pi over 3. So you notice we never got to negative 2 pi over 3. So that is why this was never going to be the answer. But you can see here we have positive 2 pi over 3 and negative 10 pi over 3. So therefore our answer is C. The next one, find the reference angle for the given angle, 436. So I think it would be best to kind of understand like what this angle is. Obviously, this angle is larger than 360, right? If you went all the way around, that would be going 360. So let's just subtract that 360 degrees. And 436 minus 360 is 76 degrees. Now, again, we got to also understand the definition of the reference angle. So the definition of the reference angle, so this angle went all the way around. Let me actually do this again. So this angle went all the way around, and then it goes an extra 76 degrees. Now remember, the reference angle is the acute positive angle between the x-axis and the terminal side. Also, you can see that the reference angle is going to be that exact angle. We already went around 360 and then we went an extra 76 degrees. Well, the reference angle in the first quadrant is the same measure of that. Now, obviously, these are not acute, so those don't work. And then obviously this green angle measures 76 degrees, which is positive, and acute, which is going to be our reference angle. Do that in red. There you go. All right, next one says find the exact value of the indicated trigonometric function of theta. So in this case, we have secant of theta equals 9 over 2, where theta is in the quadrant 4. So that's kind of important. Remember when we talked about our triangles based on constraints, we want to make sure that all of our triangles have what we call a central angle, and they're all perpendicular to the x-axis. So just remember, so for instance, just kind of review here real quick. Here I had no restriction, so I just drew like a floating triangle. But now it's saying it has to be in quadrant 4. And you might have another restriction here, whatever else, but just make sure when you're drawing these triangles that it's going to be in this, it's going to be one of those 4 triangles. Now this one, it says it has to be in quadrant 4. So it's obviously going to be this triangle. We know secant is hypotenuse over adjacent. So that's going to be 9 over 2. But what's important here is when we go and find the y-coordinate, we know that y-coordinate is going to be negative, right? So we got to use Pythagorean theorem here. So we're going to do 9 squared is equal to 2 squared. And let's just do plus b. So that's going to be obviously 81 equals 4 plus b squared. Obviously, we're going to get square root of 77. But again, notice that it's negative, right? So that's a negative square root of 77 because the direction is negative. So now it's saying find tangent. So negative square root of 77. Let's square root of negative 77. Let's put that in parentheses. All right, so now doing the tangent. Well, if here is my angle, then it's going to be opposite over adjacent. So negative square root of 77 over 2, which is answer C. All right. Number 38. Given that alpha is an angle in standard position whose terminal side contains the given point, provide the exact value of the indicated function -4, -3. So again, in this case, we're still going to have to draw a triangle. We're going to have to follow this result. We're going to have to follow our triangle in this regard. Do not take your secant as 1 over x because these is like your x and y's because that was for points that were on the unit circle, which we'll get to in a second. So in this case, though, let's graph it. Like if you sketch the graph, -1, 2, 3, 4. -1, 2, 3. Here is your coordinate point. And again, we want to draw this angle with this, what we call our central angle, perpendicular to the x-axis. All right? So we know that this value is -4. This value is -3. If you do the Pythagorean theorem here, you recognize that this is a Pythagorean triple. So I don't even need to be writing this at all because I know that r is going to equal 5. And since it's the hypotenuse, it's definitely going to be positive. So now it's just asking us for the secant, which again is, so here's your angle. Secant is going to be hypotenuse over adjacent. So that's going to be -5 over 4. And my voice is going. Hopefully I got some more live streams I got to do. All right. So let's try to do it. We only got 6 more. Oh, that was the break. Sorry about that, guys. Mr. McLogan is here, so we meet again. Interesting name. All right. Arson is asking, are you subbed to PewDiePie? I don't know, actually. I'm subbed to a whole bunch of people. I think I'm subbed to him. Maybe. Maybe not. I don't know. I guess we got some friends in here. Jeez, going through there. Jeffrey, which way? Nah, well, you are a good teacher, though. Good teacher. Hello, just watched your video on piecewise functions. Jesse says, help me more in my math teacher and even Khan Academy. Thank you so much. Well, you're very welcome, Jesse. Happy that I could be able to help you out with that. All right. Well, more like bad teacher. Well, thank you, Jeffrey. I appreciate you joining in the live stream so you can just let me know how you feel. But whatever, man. Cool. Hopefully, maybe I'm giving you some still value. But teacher, I have a question. Well, Mr. McLogan is big gay. Oh, is big gay. Cool. What is the pass rate of your pre-calc class? I don't really have a pass rate of my pre-calc class. I haven't calculated it out. I would probably say if I was going to look at, I don't know, it's probably 80%. I'd say is probably the pass rate, 80 to maybe 90%, right on in there. So I think less, yeah, because I think around 10 to 15% have earned around D's and F's. And obviously those aren't all F's, so D would be passing. So I think it's right around a 90%, 98%. I'm not sure with your username why you really care so much about my pass rate. But either way, if you have some questions, that's fine. I'll take it. Denny Den, membership, yay math. Well, that's awesome, man. Hey, I appreciate you being a member too. Obviously I will go ahead and, this will be available too as a post, for you guys to go ahead and take a look at in that members area for you guys. So I do appreciate you being a member, and look at your cool little emoji. I got to do some different ones. I got to get some cool emojis for you guys that are, supporting me with creating a lot of this content and making some videos. So I just haven't thought of what actually I'd want to do as far as a emoji or kind of a little, whatever we call them for people when they want to chat. So I gotta put my brain together and think what would be something that would actually be pretty cool to use, and have somebody obviously have somebody go ahead and design them. By the way, I appreciate this late night before my test. Well, you are very welcome. Yeah, I'm going to keep on going here for another 20, 30 minutes. So actually, I only have 6 more questions. So, once I'm done, I'll just keep on going until, you guys maybe have some more questions. This year, I am only teaching pre-calculus. Last year, I taught calculus, and then and calculus as well. But I've taught everything from Algebra 1, Algebra 2, geometry. The only thing I haven't really spent time teaching is statistics. And so that is maybe one thing that I'll look into. And obviously maybe even further advancing my career, going into some more upper level mathematics courses, I think would be pretty fun to continue to do for you guys. As of right now, though, what I'd like to do is, this has really been my pilot year as far as making this content. But what I'm going to look into doing is possibly doing something similar like this for Algebra 2 and doing that for calculus as well. And then obviously moving into some different content areas for you guys. So, all right, well, we're almost done, guys. This is the last page, or second to last page here. And then we'll be all finished. And if you guys have some more questions on anything you're covering in your own classes, I'll be happy to cover those for you. So, all right, next one says, use the coterminal angle to find the exact value of the expression. Do not use a calculator. Well, good thing I don't have any calculators here at home either with me, so don't even need to bother. Now, again, we don't really need to use the coterminal angle. We just need to know where, really, you could use the coterminal angle. And what they mean by that is if you have, 7 pi over 3, remember when we talked about the revolution? That can be broken down into 6 pi over 3 plus pi over 3, right? And if you were to graph that, 6 pi over 3 is all the way around plus an extra pi over 3. So we don't really need to go around that revolution. So by saying using the coterminal, they're just saying use the coterminal angle to really, these are equivalent expressions. So now I just got to figure out, what is the it doesn't matter if you go all the way around once and then go pi over 3, or if you just went pi over 3. You're still going to get the exact same point right up here. And let's look at this point. It's in the first quadrant. So therefore, that's going to be 1/2 comma square root of 3 over 2. All right, now the cotangent is x over y. So the cotangent, let's write this out. Cotangent of, I'll just write this as 7 pi over 3, is going to equal 1/2 over the square root of 3 over 2. I'm not going to do this work because I've done this so many times in my class. Multiply by the reciprocal, rationalize the denominator. You'll get the answer D. Next one is using the reference angle. Again, this is helpful to make sure you can just kind of like sketch, know where this graph is. So again, if you're to, halfway around a circle is pi. Again, notice guys, we're going in the negative direction here. It's a negative angle. So if you broke this up into thirds, we need to go 2 pi over 3. Now again, don't forget this point. Like this point up here, which we just did, is positive 1/2 comma square root of 3 over 2. These 2 points have the same reference angle. That reference angle and that reference angle are the same. And what that means is then their points are going to be exactly the same. The only difference now is this is in the third quadrant. So now I have a negative 1/2 comma negative square root of 3 over 2. So if I'm looking for the sign, again, since this is a point on the unit circle, I know that the hypotenuse is 1. So now I can just refer to the y-coordinate, which is negative square root of 3 over 2. And we know it has to be negative because it's in the third quadrant. This is definitely not the correct answer. And the only other one we could make our mistake on, which would be, actually, hold on. 1/2, yes, that's good. Would be this one, would be tricky, which, again, I was like, oh, let me check that out real quick. Number 41. So now we're doing some angles, or our angles in degrees. So, but again, really, this is the same thing. We're going to look for points on the unit circle. 360 degrees is going to take us to, if we were to graph that on the unit circle, that's going to take you to the coordinate point 1, 0. So the cosine is 1, which is the x-coordinate, minus 4 times the sine of 90 degrees, which is 0, 1, which is times 1. So really, the question is just asking, what's 1 minus 4? Negative 3. Determine if the function is periodic. If so, state the period. Well, remember the periodic means it's going to repeat itself, and there's nothing in this function that is basically giving me any indication that it's not going to continue repeating. It looks exactly the same as every other function we've worked on, so I'll say yes. Now, to understand the period, we need to identify b, because remember the period is 2 pi divided by b. And this is not written in our form b times x minus c. So what I'm going to want to do is I'm going to want to factor out my b. Now you actually don't need to really do this. You could actually just remember that x divided by 4 is the same thing as 1/4 x, right? So instead of dividing by 4, you can multiply by reciprocal. So what I mean by that is you could rewrite this as 2 sine of 5 over 6x plus pi halves. And that's really all you need to do, because actually dividing out that b completely from the pi halves is really just more work. If you needed to find the phase shift, though, that's something you need to do. But in our case, we just need to figure out our b. So this is 2 pi divided by 5 over 6. In this case, I will show multiplying by the reciprocal on the top and the bottom. And therefore, you'd get 12 pi over 5, which is right there. All right, 2 more to go, ladies and gentlemen. I think now 3 more to go. Determine the range of the following function, y equals negative 2 cosecant x minus pi plus 2. So what I'm going to do is I'm going to kind of sketch the graph. Now, again, notice that the x minus pi, that's going to be a phase shift pi inch to the right. Like if I have a graph and I shift it to the right, the range did not change. Up and down did not change. So I don't really even care about this. I only care about what's happening vertically to the graph. You can see that the graph is being stretched by a factor of 2, as well as being shifted up 2. And then the reflection, though, is not actually going to change the range at all. If you look at a graph and reflect it, it's not actually affecting the graph at all. So just remember the sine graph, or the cosecant graph, is the reciprocal of the sine graph. So let's just say here is the standard initial period of sine, which I want everybody to know. So if this graph is being stretched from 2 to 2, like this now, and then it's being shifted up 2. So now 3, 4. So now the graph is going to go from like here. So that would be 2, 3, 4. So it's going up to 4, down to there. new horizontal not asymptote, but this new x-axis kind of got shifted up there. Now, again, that's not what the graph looks like. That is what y equals 2 sine of x plus 2 would look like. Again, I'm not including the reflection because if you were to take the red graph and reflect it about the x-axis, it's still going to have the same range. So you apply the reflection before you do the shift. And then I'm not going to worry about the x minus pi because that's just shifting the graph left and right. However, this is the sine graph. And remember, when we're looking at the cosecant graph, we're basically looking at this brown graph from here. So you can see that the graph is going to continue from negative infinity all the way up to 0. And the only range that has that is d. And then it continues from 4 to infinity. So the only one that's even remotely close is d. And again, I think it's easier to understand the transformations, understand the sine graph, and then understand how the cosecant graph relates to the sine graph. You don't need to be able to graph it, but you do need to kind of understand those portions. So I got 2 more problems, which is going to deal with the inverse. And I'll just kind of check in with you guys. Sharky says, I have no idea why I'm here. I don't know why you're here there either, man. I'm doing a pre-calculus review session for basically my students and anybody else that's taking pre-calculus. But it does cover functions, polynomials, rational functions. So basically a lot of Algebra 2. If you're in Algebra 2 all the way up to calculus, I'm sure you can probably find some value in a lot of the problems that I am doing. Caitlin Lou says, can you explain to me why arc cosine of -1 equals pi? Yes, I can do that for you. Spencer says, hey, dude. Well, hi, Spencer. How are you? Brunson says, a student from Toronto taking advanced functions grade 12 university course. Well, awesome, man. Happy to have you joining in on your advanced functions for grade 12 class. Hopefully some of this content, obviously, I teach down in Florida, United States, so I'm not comfortable with whatever your curriculum is, but hopefully some of the problems that I'm working on is similar. So cosine inverse of -1. Why is that equal to pi? So I'll do that next. Anybody else have any other questions? I know that I had a couple ones as far as some advice on being a teacher, which actually I'm just going to address that right now because that's actually something really quick that I can get to. Where was that? Who was that? Yeah, Grace says, hey, I found your videos online and I was wondering if you could maybe give me some advice. I am a grad student and I am taking up teaching at high school to help pay for that. I am very worried about it. Gotcha. Okay. So it doesn't look like you're just looking into, obviously, to help pay yourself kind of way through grad school. You're not really going into the profession from that thing. Hey, I mean, the reason why I got into teaching was because, I wanted to not really make a difference in everybody's life and change the world, but I definitely saw I wanted to change the way that people learned math. At least for me, I didn't enjoy 100% the way that math was taught to me. It was confusing. I struggle with it, and I had a mission to change the way that math was taught. And I absolutely abhor when I hear people say that, I'm not a math person or math is too hard or I hate math, and so I'm like, and to me, I know that majority of them just never got a shot. They never got access to some quality education. And I'm not even close to where I want to be as far as quality education. But, I think the fact that people have grown up and grown-ups, I mean, they literally, they'll tell me straight away, oh, I hated math or math's stupid. Math you never use in real life. I'm successful and I never use math. And that's really because what we've done to math education. I mean, we've boiled it down to these things you got to memorize to be successful. And it's to get past these tests, to get into these colleges and whatever else. And we've just kind of treated it as a tool. And that is completely 100% not what math is about or not the purpose of learning mathematics. And unfortunately, it's just kind of, that's what it's kind of boiled down to. And we've created generation after generation of just hating mathematics because what do? We just force people to, solve these problems. We force them to memorize these tricks. And if they're not good at doing that, then they're not considered smart. And then they have to spend all this extra time at, time learning with tutors and all this stuff just to play the game to pass the test, which doesn't really have much impact on their life. So, those are some of the things I think about And, my thing is, when you become a teacher is, looking into just having fun. I mean, there's been a lot of years that I've had a really, really, some tough years as far as teaching goes. And, you want to quit, right? And you're just like, man, I don't know if I can do another year. And, some of the things obviously that always kept me there was like my why. Like, why did I want to be a teacher? Why did I want to impact students and make an impact on, math education? And if teaching's not one of those things that you have that big why for, but it's kind of one of those ends and means, I would just look into like, how can I make every single day, an enjoyable experience, not only for myself, but for my students. I mean, you like it or not, you're entering a profession where, people are going to, look up to you. They're every single day, no matter how you're feeling, they are going to be, looking up to you and looking for you for inspiration, looking for you for motivation, and for knowledge. And, that's kind of what you sign up for when you decide to become a teacher. And, I would just say like, you're not going to hit a home run. You're not going to, always become everybody's favorite teacher, and nor do you really want to strive to be that. I think what you'd want to do is just strive to deliver as much value to the students, have them enjoy learning, and then also make that enjoyable yourself, because even if like teaching is not an end for you, you want to make that a great experience. And unfortunately, we do a lot of things in our education sector that, compresses a lot of that creativity of the teachers. But I think if you can just do your best, you can have a great shot with it. So hopefully, Gray, that helped you out. All right. So do you have a program? So Denny, okay. So let me come back up here. Spencer, breeze through algebra 1 geometry is fairly easy. Start algebra 2. Yeah. And that's not a problem. I basically had to take algebra 2 again. I mean, because I just breezed through the material, didn't really learn anything, just memorized stuff. And then by the time it came for me to like actually learn it, I was kind of screwed. So I would definitely say that, yeah, I mean, a lot of this stuff that you probably might not have conceptually learned, you're going to want to probably go back and practice those. And, a lot of this stuff looks easy, when I'm doing it. Well, because I've been doing problem after problem after problem after problem, right? But it wasn't like that for many, many years. I had to go back and practice and remember a lot of things. Mario, thank you. Mario Mora, thank you so much. Greetings from Mexico. Well, happy to have you on the stream, Mario. Jacobson, I was wondering if you had any videos on finding standard form of a parabola with only 2 points and no vertex. No, I do not. I have ones for when you have 3 points with no vertex, but I'm not sure 2 points with no vertex what you would want to do. I know when you have 2 points in a vertex, you're just plugging it into vertex form. When you have 3 points and no vertex, then you can use a system of equations to use the 3 points in standard form and then use a system of equations. But I'm not really sure what you would do, or if that is possibly enough information, just given 2 points to find the vertex. I haven't done any of those problems in a long time, or if at all. So I wouldn't really know exactly the best thing unless spending some time looking at the problem to really determine it, which for this live stream, I don't really have the time for that to do. Do you program as well like Java? Denny asks, no, I do not do any programming though. No, I'm like, even like my websites, I do a lot of, I actually have to hire a lot for the website stuff. So no, I'm interested in a lot of this stuff, but I kind of came late to the party. And like, as far as I was not meaning like you can't code now, like it's too late. But what I mean by like, I kind of got interested in so many other things, like fully developed, that by the time like I was like, oh, coding's really cool, like my time to invest in that was kind of already taken up with all these endeavors. Like for instance, now, I mean, all the stuff that I'm doing for this pre-calculus class, I mean, during class, during school, after school, late at night, like I barely have enough time, taking home my kids, making dinner. It just really takes up a lot of even my extra time for me to really do a lot of any other things outside of that. So, no, I've really never gotten into coding. What really just kind of made math interesting to me was I just enjoyed, like I just enjoyed I really what really makes me connect about math, which makes me sad when so many people say I hate math and, you know, I'm not taking any more math classes, because it really wasn't until I got outside of calculus after Calc 2 and I started taking these advanced math courses, I really started to see, oh my God, everything that I've learned before is like now super connected. And like I never made those connections before. I was just independently doing all these math topics. And, you know, I never made the connections. And then it wasn't until I made those connections I was like, oh, this all makes sense. This is what I love. So, yeah, Arson, no worries, man. I'll past bedtime. Oh, man, I'm getting through these. Do you study the teachings of Mike Hunt? No, I do not study the teachings of Mike Hunt. Do you have an easy way of factoring the equation completely? Well, just make sure you give it as a list of factoring where into linear factors, you know. I mean, there's a lot of different techniques for factoring, a lot of different types of problems you can do. Obviously, I think on my I have a lot of, you know, worksheets that I have too, as well as for the factoring ones that, you know, yeah, it really kind of depends, just like on Orgeman said, you know, it depends on what are you looking at trinomials, you know, polynomials, polynomials with 4 terms, with 2 terms, you know, difference of, in general, with cubes. Oh, like the difference of 2 cubes. Yeah, that one's not as fun, but I could do a problem like that if you want me to. Like, for instance, I mean, hopefully you'll let me just do one simple like this, 8, and like x cubed plus 8, and like just factoring that in general. Or are you looking, I don't know why I said difference of 2 cubes, because you just said factoring with cubes. So any kind of cubic function, I did one of those up here, actually. But I can do one. Maria, if you have a question, I'm going to knock out these 2 problems. I've been rambling for a long time now. So I'm going to knock out these 2 problems. I'm going to do this one, and then if anybody else wants me to do C and D, then I will be happy to add those in there as well. So just let me know, guys. I'm going to leave these 2 open, and then I'm going to let's do these problems. So for those of you that are actually waiting for me to get into my math, let's go ahead and do the sine inverse of negative 0.5. So again, this is written as a decimal, but again, guys, just remember this can be rewritten as negative sine inverse of negative 1/2. And again, guys, what this is asking is the sine inverse of negative 1/2 is basically saying the sine of what angle is equal to negative 1/2. And again, when we look at the unit circle, we see that, well, there's actually 2 values, 2 angles, where the y coordinate is equal to negative 1/2. We have this point, which is square root of 3 over 2, comma, negative 1/2. And we have this coordinate point, negative square root of 3 over 2, comma, negative 1/2. And the problem with having 2 answers is this is the inverse function. You can plug this into your calculator, but if you plug this into your calculator is not going to give you not even one, not both of these angles, and actually not even either of these angles. And so the reason why is we have restricted the sine function to evaluate for the inverse. And you can't plug in sine inverse and expect to get those 2 angles. And it doesn't even matter what those 2 angles are, even though they are 7 pi over 6 and 11 pi over 6. But either way, neither of them are correct. And the reason being is because they don't fall within the restriction. And when we're doing sine inverse, remember that the restriction of the function is within negative pi halves to pi halves. And you can see for both these angles, even though the y coordinate is negative 1/2, this one definitely isn't even within the restriction, and this one actually escapes the restriction and then comes back in. But what we need to do to fall within the restriction of sine inverse, we need to stay within the restriction. So the angle that's going to produce this point that stays within the restriction is going to be a negative pi over 6. Now, if we were just to talk about solutions, right, like sine of theta equals negative 1/2. Is 7 pi over 6 a solution? Yes. Is 11 pi over 6 a solution? Yes. Is negative pi over 6 a solution? Yes. So they're all solutions of this equation. But again, I'm only using this equation to understand what the sine inverse is asking us, which is the angle. But it's with the angle that is restricted between negative pi halves and pi halves. And that's going to be the same restriction for sine as well as tangent. and I just noticed this, so I'll just go and get this. How would you know if you have to do inverse operations? I'm not sure what you're talking about, Paulo, as far as like what to do inverse operations. If you can maybe give me an equation, what you're dealing with, then I can go and explain that a little bit more. Now this one's a good one. I really like this question. So this one says, find the exact value of the expression, do not use a calculator. So we're thinking about this. We say 4 pi over 5, and I'm like, oh crap, that's not on the unit circle, right? So what is the sign of 4 pi over 4? I can't actually figure out the sign of 4 pi over 4, nor can I find the inverse of that. However, let's go ahead and do something similar. If I notice this, what quadrant is this? 4 pi over 5. If I was going to take a circle, break it up into 5 parts, which is kind of weird. Let's say 1, 2, 3. Let's do something like that. 1, 2, 3, 4, 5. Well, if I was going to do 4 pi, that's in the second quadrant, right? So let's find another angle that's one that we're more familiar with. That would be in the second quadrant. Let's do 3 pi over 4. So if I was going to do 3 pi over 4, I just want to do something that's a little bit more familiar. So if I said the sine inverse of sine of 3 pi over 4. Okay, now the sine of 3 pi over 4 is obviously going to, of this coordinate point, is going to be square root of 2 over 2. Then the sine inverse of square root of 2 over 2 is just going to equal pi over 4. Now you might say, all right, but how is that going to help me with this? Well, the important thing I want you to understand is, remember when you're doing sine inverse, it has to fall within this restriction, right? So what we really are doing when we're taking sine of 3 pi over 4, we're noticing that it's basically going to be the same angle as that reference angle. These 2 points, this is in the first quadrant, this one's in the second quadrant. They have the same coordinate points. I'm sorry, the y coordinate is exactly the same. So when you take the sine of pi over 4 and you take the sine of 3 pi over 4, they're both equal to 1/2, right? I'm sorry, they're both equal to square root of 2 over 2. But when you take the sine inverse of square root of 2 over 2, you're only going to get pi over 4 because pi over 4 is the only one that falls within the restriction. So what we want to do here is figure out what is this reference angle. So the reference angle, again, is going to be the positive acute angle between the x-axis and the terminal side. Well, halfway around circle is pi. In terms of fifths is 5 pi over 5. So halfway around circle is 5 pi over 5, and if this is 4 pi over 5, that means the reference angle is going to be pi over 5. So when I do the inverse of that angle, again, it's going to be the same over here, but this angle is what falls within the restriction. So I'm not sure if I did a good job explaining that or not, but I think it was a pretty interesting question. All right, so let me go and knock over these 2, and then I'll kind of scroll back and see if there's anybody else that had any questions that I can help out with. All right, cosine inverse of -1, and again, that is if you understand, that means the cosine of what angle is equal to -1. And if we just go ahead and sketch the unit circle, and we say, well, when are we going to get -1 for an x coordinate? Well, that's going to be right here. And that angle is pi. So if I don't have to do this, I'm not going to do this. But I can be more than happy to help you out with any kind of factoring problem. So let's go and see here. I got just a little bit more time. See if you guys have any questions. Rockwood, Tennessee. All right. Who else is having pre-calculus final tomorrow? Hopefully, I'm so glad I did this. I was going to wait to do this final. I was going to wait to do this video on Wednesday. So I'm so glad for those of you that have your final. Hopefully this can help you guys out. And again, guys, what I will do is, especially for those of you that maybe missed part 1 and you don't want to go back and skip over the chatter and get to the math, I will, once I get off this live stream, I am going to export this to a PDF and then upload it, and I will update the description. So therefore, you guys can go ahead and download this as well as a blank copy to go ahead and practice on your own and kind of check your work with mine. And then obviously, if you kind of forgot, then you can always come back to the stream and check what I have here. So Jacob says, sorry for the interruption. Been watching your vids for polynomials for a final tomorrow on pre-calc. Your videos have helped out. Well, awesome, man. So happy to be able to help you out. Trig final exam tomorrow. All right, Orange Mets. That's awesome. Good. Best of luck. know that unit circle. Run through it a couple more times. Should I memorize the unit circle for these questions? Well, I'm not sure what you mean for these questions. I mean, for the inverse functions, you got to know the unit circle. I'm not a big proponent. If you've watched any of my content in trigonometry, I'm not a big proponent of memorizing the unit circle by any means. It's kind of a little, the way I go about it is a little bit different. As far as basically, if you look at the unit circle and you look at the first quadrant, all these points in this first quadrant just repeat themselves, right? They're just reflections about there. So basically, I mean, like for instance, this angle, what I like to do is I find the angle, I find the reference angle. Because whatever that reference angle, it's going to be the same point as the same reference angle in the first quadrant. The only difference is the coordinate point's in a different quadrant, so therefore you're going to have different coordinates are going to be positive or negative. So that is just kind of a rough summary. You definitely need to know the first quadrant, and then basically just kind of apply that to your angles. But I have a ton of videos explaining my kind of method that would probably be more useful for you. You should only memorize the first quadrant. Exactly. There's no point in memorizing the whole circle, and I cringe anytime I see anybody or a teacher telling them they should do that. I mean, obviously, you're never going to use the unit circle like in your real life, and knowing the first quadrant is sufficient for any math problem, as long as you know how to adjust it. Any of you go to TAP High School? What was the question? Is there any way to solve without the unit circle? Because at my school we don't use it. Yeah, Well, I mean, if you don't have a point that's on the unit circle, you still use triangles. I mean, it's still the same thing, same idea. But you'd have to talk about a question as far as when the unit circle would be applied or not applied, Caitlin. But I mean, the unit circle is just a tool. Remember, like if I have a triangle, for instance, here's a triangle. Scroll that up. I was talking to somebody. But let's just pretend here's a triangle. Here's 5, here's 10, right? And then this is 30 degrees. If I said find the sine of 30 degrees, you'd be like, okay, that's opposite over hypotenuse. Done. Now, all the unit circle is what we've done is we've reduced the hypotenuse to be 1. So it's the exact same triangle, or it's a similar triangle, what we call it, but now it has a hypotenuse of 1. 5 divided by 10 is 1/2. So now, when I want to find the sine of 30 degrees, instead of doing opposite over hypotenuse, I can say that's just equal to 1/2. And that's basically what the unit circle is made up of. It's made up of special right triangles with the hypotenuse of 1. That's why we only refer to it as the x and the y coordinates, because you're putting them over a hypotenuse of 1, which just makes it easier. But it's not necessary. You can create a triangle for any single for most of the problems you're doing. Except when you get to the x and the y axes, that's where things kind of get a little more confusing. All right, good night, Sam. Best of luck on your test. Let me see if there's any more questions. Anybody else that's hanging out that I can help for you on there? Can't you just do 2 pi, negative 2 pi, then evaluate to make it easier? You could. I'm sorry, I'm kind of working my way backwards, so I'm not sure which problem you were talking about. Ozzy, can you show me how to find the zeros of a function? How do you know how to find the inverse operations? Did you get Yankee? Boy, yes, I did get the silver play button. So it's really cool. Really, really happy to have it. It was a really cool kind of accomplishment, especially for, making some videos for so long and for so many of you guys that have, reached out to me as far as my videos helping you guys out. So it's definitely been a really cool accomplishment and something really cool to kind of get in the mail from YouTube. As far as finding the zeros, I mean, there's so many different ways to find zeros. That's like a really, really loaded question. Just the main important thing, I'd say when you have f of x equals, dot, 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 dot. Remember the zeros are when f of x is equal to 0. So, I mean, you can use factoring, you can use synthetic division. A lot of times we're using long division. A lot of times you're using graphing. Sometimes they're in factored form. We use a zero product property. So, I mean, I have a whole bunch of videos on zeros of the function. Unless you have a specific problem, that's not really a topic I could probably do a whole another 2-hour live stream talking on that stuff. Okay, well, essentially for domain, you look at the x values to define. Well, thank you, Orange Mats. I appreciate that. I'm sorry I'm taking Algebra 2. Please don't stop making videos. I will not keep on making videos. I have a lot more content still to go. So you can be sure I'm going to continue doing that. Do one on domain and range. Oh, sorry, Joanne. Do one on domain and range. How do you simplify a radical? All right, so now the questions. Why does the questions already come in when I'm already done? So, I mean, the main important thing, guys, that I would probably say, when we're looking at domain and range, I'm just going to give you guys the simplified version because I think all the math stuff gets people confused. When you're looking at the domain and range, like here's just a graph, and let's go from like down here. Let's just do a simple graph here. The domain is the set of all x values that make up the graph. So you can see like here's the x-axis. And remember the x-axis is just a number line, right? Remember like when we used to count on the x-axis, it's just a number line. So what are all the values that make up this graph? Now, I just kind of made this up, but you can see like the graph only goes as far left as 1, 2, 3, 4, 5. So we'd say the domain is from -5 and then all the way to 1, 2, 3, 4, 5, 6, 7. So we'd say the domain is from -5 to 7. Now 7 is actually not a value, so it's undefined, so we use parentheses. Now I'm using interval notation. There are multiple different ways to be able to write domain and range. This is just one of those notations. So domain, the way that I kind of like explain domain in just like simple terms is it's basically how far left the graph goes, how far to the right the graph goes. If you're looking for domain algebraically, then you're looking at discontinuities, and that's something that I talked about in the live stream on part 1. So I definitely go and check on from there. And then when you're looking into the range, it's basically saying how low does the graph go to how high. And the easiest way to find the range of the function is to find the domain of the inverse. And again, that's something else that we covered in this live stream. But in the example in this graph, it'd be -1, 2, 3, 4, 5, 6. And that is not closed. So that's -6 all the way up to 1, 2, 3, 4, 5. So again, these are the values that make up the graph. Now, simplifying radicals. Well, let's just do something basic. We know the square root of 9 is equal to 3, right? Because 3 times 3 is equal to 9. So if I was going to say, what is the square root of 18? Well, I don't know the square root of 18, right? However, I can rewrite this as the square root of 9 times 2. Now, using the rules of radicals, and you can check your work if you want to. One of the more popular ones that I always do is, square root of 9. All right, let's do this. Let's break it up. Make sure to see if these are all the same. Square root of 36, right, is the same thing as the square root of 9 times 4, which is the square root, same thing, as the square root of 9 times the square root of 4. So you can see as each one of these representations is different, but they're still going to all give you the same answer. So what that allows me to do then is to break this up and do the square root of 9 times the square root of 2. Now I know the square root of 9, which is 3, but I don't know the square root of 2 as far as a numeric representation, so I just have to leave that as the square root of 2. So hopefully that helped. Can you go over ellipse and hyperbolas? Bridget. Go over ellipses and hyperbolas. That is kind of a lot. Because that's kind of like a review, like a whole review. Like there's a lot I could talk about those, and I really don't have the time to kind of cover I mean, if you look up ellipse and hyperbolas, I probably have like over 50 and 60 videos of different problems that I've solved. Unfortunately, that's going to be probably the best because anything that I can explain to you, because you're just asking a very general question, I I probably would spend 5-10 minutes just talking about something you probably don't know. So, or not that you don't know, but that's not going to help you. So if you have a specific question, I can address it. But just a general one, I'm not really going to spend too much time on just because I don't know what is going to help you or what would already be something you know. So arc sine of square root of 3 over 2 equals pi over 3. That's correct. Thank you, Archibald. So how do you evaluate arc cosine of 11 pi over 6? All right, Caitlin, well, I'm not sure, Orange Mets, if you got this one, so I'll just go and do it just for fun to explain. So we have arc sine of 11, well, so that one really doesn't make as much sense because that is basically giving you your value. You're going to have to use a calculator. Because remember, first of all, when you're using the arc sine, now remember arc sine is the same thing as sine inverse. All right. So when I say like the sine inverse of 1/2, what does that equal? Well, that's going to equal an angle. When you're doing the sine inverse, you're looking for an angle. So that's why this one doesn't make any sense, at least in our general sense, because you're saying the sine of what angle equals 11 pi over 6. Well, that's going to be some weird angle that's going to give you 11 pi over 6 as your ratio. It's definitely going to be a decimal you're going to want to go ahead and use a calculator for. Typically, when we're looking at this, like a problem like this, we're looking at the points on the unit circle. So this would be like sine inverse, So you take the sine of angles, right, is equal to 1/2. Because remember, our trigonometric functions are based off of triangles, right? Here's a triangle. We're trying to evaluate our trigonometric function. It's the sine of an angle. So what this is doing, when we're doing the inverse, we're trying to find the angle. That's why this one, if you think of 11 pi over 6 as an angle, this wouldn't make any sense. Now, 11 pi over 6 is just a number. So this technically isn't wrong. You would just have to use a calculator, though, to evaluate. Good luck, Nathan, on your exam tomorrow. Wish you the very best. How long have you been streaming today? I did an hour and 15-minute stream after school, and then let's see where I'm at today. I'm at an hour and 16 minutes right now, so that's 2 hours. And I'm thinking about going live tomorrow, too, so whatever question you guys have, I'll be able to help you guys out, hopefully. We'll see. How do you solve a system of linear equations? The one where you have to find x, y, and z. So that'd be a system of 3 linear equations. I'm at my point where, guys, I need to sign off. That would be a system of 3 linear equations. I do have some videos and to help you out with that, though. But unfortunately, I'm just not going to have time to do, one of those full kind of problems. So sorry about that. And Algebra says algebra. Cool. Algebra. So anyways, guys, as of right now, this will be up there. If you guys want to have a copy of this, it's going to be in the description here. Give me maybe about 30 minutes to an hour, and this will be up there for you. I'm also going to put the link into my previous live streams. So therefore, any of you guys that are, want to go back into the archives and kind of look at some of the other problems, some of the topics that I've covered in terms of homework and quiz answers, I'll have those available. I'll show you the link to the playlist for you guys. And then I'll have a blank copy of this review as well as the filled in one, so you guys can just kind of follow along. And then well, hopefully tomorrow I will go back live. So therefore, if those of you guys take an exam on like Wednesday or Thursday or Friday, I can help out. And maybe on Wednesday we'll do the same thing. But yeah, definitely Purple is right, guys. Good luck. Keep on studying. Remember, do all the problems you know how to do first. Don't waste your time doing a problem that's taking as much time. Work on those ones that you know how to do first. Follow your gut. That usually is going to be the correct solution. And remember, just be careful. I am the king of making some minor mistakes because I'm not paying attention or being careful. So be careful out there. If you have extra time, check your work. I am signing off, guys. Have a good night.